Hello everyone. Today we are going to discuss about the numerical solution of ordinary differential equation by using Milne's Predictor Corrector method. As it is mentioned in a Predictor Corrector that we have to just predict the first value of function f for x, and then we will correct it by using corrector formula. That means we will get more accurate value after correcting the predicted value. Yes, this is the working rule. If we have a differential equation in this form and only the initial condition is given, that is y at y0 and x is x0, that means the value of y is given for the x0, for the value of x0. Then we have to find out the value of y1, y2 and y3 by using Picard method or Taylor series, but I recommend to use Picard method, which was previously taught. Now, by using the predictor terms means this formula, because we have already calculated the value of y1, y2 and y3, and y0 is already given. Y0 is already given. So when we replace n is equal to 3, we get the value of y4 by predicted, because the predicted formula required the last three terms of function, that is the f3, f2 and f1. For these values we required the term y0, y1, y2 and y3. After substituting the value of y0, y1, y2 and y3, we will get y3 function at f3, function at 2, function at 1. By using these terms we will get the value of y4. Then after substituting the value of y4 in corrector formula, we will have the value of y4, corrected value of y4, by using the function value of y4. To calculate this f4, we required y4, the predicted value. So the process is continue for second iteration. This by if the h is equal to 0.5, then and x0 is equal to 0, then by using first term hx0 we will at y4 when x is 0.5. Again if we use this process, then we will be at y at x value 1, at the value of x is 1, because 0.5 plus 0.5 we will be at y is equal to 1. Now by using Milne predictor corrector method, we have to find out the solution of this differential equation, that is dy by dx is equal to 1 by 2x plus y in the range 0 to 2. For the conditions of these conditions are according to the when x is 0, y is equal to 0. I am writing x0 is 0, at that time y0 is 2. When x1 is 0.5, y1 is 2.636. When x2 is 1, the value of y2 is 3.595. Then the value of when x3 is 1.5, the value of y3 is 4.968. So these values are given in this problem. These three values are given. If these three values are not given in a problem, if only this initial condition is given when x0 is 0, y0 is 2, we have to calculate these three values by using Picard formula or Taylor series. Now we have to find out the value of f1 is 1 by 2. The value of function is this 1 by 2 x plus y. So for f1 we required f1 is equal to 1 by 2 of x1 plus y1. The value of f2 is 1 by 2 x2 plus y2. The value of f3 is 1 by 2 x3 plus y3. So by calculating these value, we received f1 is 1.568, f2 is 2.2975, and f3 is 3.234. I have calculated these values, so I am writing down the values directly. Now we have to calculate the value for the predicted term. According to the predictor formula, yn plus 1 is equal to yn minus 3 plus 4h by 3 into the twice of fn minus fn minus 1 plus 2 fn minus 2. Now substituting the value of n is equal to 3, we get y4 is equal to y0 plus 4h by 3 into 2y3 minus function at 2 plus 2 into f sorry 1. Now substituting these values y0, f3, f2 and f1 and h. Remember, according to these x0, x1, x2 and x3, we can easily calculate that h is 0.5 in this question. Now substituting these values, we get y4 is equal to 6.871. This is the predicted value. This is the predicted value that our solution is near about this. Now we have to use the corrected formula. Before using the corrected formula, we required f4. f4 is 1 by 2 x4 plus y4. That will be 4.4355. Now 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 by the corrector formula, yn plus 1 is equal to yn minus 1 plus h by 3 into f of n plus 1 plus 4 fn plus fn minus 1. Now we substitute these values. I am just writing the c for the corrected value of f, y and n is equal to 3. We will have y4c is equal to y2 plus h by 3 into function at 4 plus 4 function at 3 plus function at 2. For this value, for function of f4, we use predictor formula. Previously we have calculated the value of y, then we have calculated y4. We have calculated y4, so that y4 will be used over here. So by substituting these values, we get y4 corrected value is equal to 6.872. This is the first corrected value, C1. I can say that this is the first corrected value, but we don't know how much decimal place it is correct. So we use corrected formula again, but before using it, we have to find out the value of y4 for first corrected value, that is 1 by 2 x4 plus y4 at first corrected value for C1. Then after calculating it, we will get 4.4365. Now we are using the corrector formula y4c. For 2 is equal to y2 is same plus h by 3 is same, but over here we will use y4 at c1 first corrected value plus 4 f3 plus f2. Only this portion is changed. In the previous formula, in this formula, everything is same, but this function corrected value is changed. Now again calculating it, we will get y4 c2. The corrected value is 6.8733 and the previous value is this. So by comparing these values, we can easily calculate that up to 3 decimal place the value are repeated. For 3 decimal place the value of y when x is 2 is 6.873. This is the approximate value. So this is the solution. We can use it corrected value to recollected and increase the accuracy in the decimal place. Thank you.